Hello, my name is Andres Ginebra and this is the charged tapes lab. So the purpose of this lab was to observe the interactions between charged pieces of tape and determine the tape's excess charge. We used two fundamental equations for this lab. The first one was the electric force one and the second one was the gravitational force one. The experiment. Basically, we just had to charge two tapes, observe the interactions between the tapes and other objects, observe the interactions between the two tapes, and also see what are the excess charge of the tapes by making the tape float. My expectations were that the two tapes were going to have the same charge, of course, because they were drawn from the same tape. So my data, I had a 20 centimeter tape and the mass of that tape was 0.0002 kilograms. The distance between the two tapes was 3 centimeters. Magnitude of the gravitational force, which is just mass times gravity, as I showed before, I get 0.00196. And the electric force should be the same, since when the tape is floating, it means the net force is zero since it's not moving. Observations and the conclusions. So the charged tape was attracted to neutral objects. I tried a book and I tried my hand and it was attracted to it. The two charged tapes repelled each other, so that meant they were the same charge as I expected. The charged tape was attracted to a negatively charged pen. So this means that the U tapes are positively charged, because first they were attracted to the pen, which had a negative charge, and they were also attracted to a book which has no excess charge, which is neutral. This is a free body diagram which shows tape B at the top, which has an upward force coming from tape A, and that force is the electric force. Then it has a force going downward, which is a gravitational force. So for calculating the excess charge, I just set equal the magnitudes of the force due to gravity and the force due to the electric. Basically, once I set those equal, I found that the excess charge was 1.4 times 10 to the negative 8. To calculate the fraction of atoms that gave up electrons, first I had to calculate the number of electrons that were giving up. So I just divide the excess charge by the charge of an electron, and I got 8.75 times 10 to the 10th. And then I found the surface area of the tape. That surface area was 0.0035 meters squared, and the surface area of an atom, I got 1.1 times 10 to the negative 20th meters squared. So to calculate the number of atoms on the surface, I just divided the surface area of the tape by the surface area of the atoms, and I got 3.5 times 10 to the 17th, and that is the number of atoms on the sticky surface of the tape. To calculate the ratio of this, I just took the number of electrons I had before and I divided it by the number of atoms on the surface, and I got that for every atom it was 2.5 times 10 to the negative 7 electrons lost. This means that 2.5 times 10 to the negative 5% of the atoms in the sticky surface lost an electron. And for the coating part, I got that the tapes have an excess charge of 4.667 times 10 to the negative 17 coulombs. The reason I think this was way lower than before is that in the program, in the coding, the distance between the two electrons, between the two tapes, was way lower than in the actual experiment. The assumptions I had to make were all these three listed below. This is a picture of the coding, and on the right you can see the actual diagram. The red is the tape on the top, which had to float, and the blue is the tape on the bottom, that exerts the upward force. I set them as point particles, of course, and the yellow arrow shows the electric force and the green arrow shows the force due to gravity. So what if the electrons had a positive charge and protons had a negative charge? What would change about the observations I made with the tapes and other charged objects? This wouldn't change. The observations would all be the same. The only difference is that instead of the tapes having a positive charge, it's going to have a negative charge. And instead of the pen, for example, having a negative charge, it's going to have a positive charge. But apart from that, all the observations would be the same. The two tapes will still repel each other, the tape will still be attracted to a neutral object, and the tape will still be attracted to the pen, because they're going to have opposite charges. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes comes into contact with my hands or other objects? So It's important because when you touch it too much, then you're giving the tape contact with another object. That contact is an opportunity for electrons to be transferred between the two objects. And when the electrons are transferred between the two objects, it takes away the net charge from the object and it becomes neutral.